Certainly, the find peak element problem is a classic problem often encountered in coding interviews. It is part of LeetCode problem number 162. The problem statement is as follows. Problem statement: you are given an integer array nums where nums I. A peak element is defined as an element that is greater than its neighbors. For corner elements, you only need to consider one neighbor. Key points: an element nums I is a peak if a 0, then nums I should be greater than nums I1. If a 1, then nums I should be greater than nums I1. For other elements, nums I should be greater than both nums I1 and nums I1. Constraints: the array will not have duplicate elements. The array size will be at least 1. Example: plaintext input nums 1, 2, 3, 1 output 2 index of the peak element 3 input nums 1, 2, 1, 3, 5, 6, 4 output 1 or 5 index of the peak elements 2 or 6 approach. We can solve this problem using a binary search approach, which allows us to find a peak in or log in time. The idea is to leverage the property of peaks in the array. If the middle element is not a peak, we can decide which half of the array to explore further based on the values of its neighbors. Binary search steps 1. Start with 2 pointers left at 0 and right at none wherein is the length of the array. Calculate the middle index mid left right 2. Check if nums mid is greater than its neighbors. If yes, nums mid is a peak, return mid. If not, check the neighbors. If nums mid 1, it means there is a peak on the right side, so move left to mid 1. If nums mid 1, it indicates a peak might be on the left side, so move right to mid 1. Repeat this process until you find a peak. Python code example here. Python implementation of the above approach. Python def find peak element nums left, right 0, len nums 1 while left right to check if mid is a peak. If mid 0 and nums mid 1, move to the right half left mid 1, else move to the left half right mid at the end of I value 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 we initialize left and right pointers. We use a while loop to perform binary search until left is less than right. Within the loop, we calculate mid and check its neighbors to decide which half of the array to search next. Finally, when the loop ends, left will point to a peak element, which we return. Complexity analysis time complexity O log in due to the binary search approach. Space complexity O1 since we are using a constant amount of space. This efficient approach ensures that we can find a peak element in logarithmic time, making it suitable for large input sizes.